AI Game Changers podcast with Luke Whips.
If you take us back to, because you studied in Bordeaux, right? And you've got a PhD in computer vision from Bordeaux. So do you want to take us like right back to then? I know that was probably quite some time ago, man. So, yeah. But yeah, do you want to take us up right back to then and give us a kind of like foundation of how all of this started for you? What inspired you to get into computer vision and AI, generally speaking? And, you know, what was the starting point for you?
Yeah, so actually, I wanted to study music production in the beginning. So, because I'm really into music. So what I thought is maybe I could write software for music. So all these plugins that you use, for example. And to do that, you need to study like signal processing, and math. So that's what I did. And then during my bachelor thesis, I had the opportunity to work on image processing. So I was working on image compression, like JPEG compression. And I actually really liked it. And at that point, I was like, maybe I can actually work on images instead of audio. And I did some research, and then I found out that actually working on images is much more interesting than audio, because you can do much more different things. Like if you, for example, if you work on music, you're only stuck with music. But if you work with images, you can do so many things. So that's how I switched to computer vision. So then I did my master's, more focused on computer vision. Then I did my PhD on computer vision. So my PhD was more on optimization. So all these math optimizers that I used in machine learning. So I'm actually a math guy. I'm not engineering. I don't have an engineering background. I have more of a math background. So in my PhD, I was designing these optimizers that are used in machine learning, computer vision, and how you can apply these optimizers on different computer vision problems. And then during my PhD, which was from 2012 to 2015, deep learning has just started to get a little bit more mainstream. And I tried to apply the stuff that I did in my PhD to deep learning. And that's how I got more involved in deep learning. So when I finished my PhD, I was working more on deep learning projects. So after my PhD, I worked for two companies doing computer vision R&D. And then afterwards, we started Mobius.
Nice, man. I never knew that you wanted to work on software. So I guess it would have been to develop programs like Logic and stuff like that, right?
Yeah, it's basically writing what is called VSTs, like virtual instruments. And yeah, I was really into that, but then I realized it's actually not a really good career, because yeah, if you do that, you're pretty much stuck with that. There's not much you can do. But with computer vision, there's so much more.
Yeah, it's
but the background is pretty much the same, It's the background is also signal processing. It's just that the data changes. Instead of working with images, instead of working with audio, you work with images.
Yeah, but so did you ever think? Because I've seen a couple of use cases recently of AI for music development. I don't know if you've seen anything like that, but I've always thought, I don't know if that. AI for art, I understand the the technical accomplishment to be able to do that, but I don't know if art, music, and that kind of stuff is a very good use, because it kind of takes away from the personal, emotional element of music and art for me. I don't know. Well, have you seen anything like that? What do you think about that?
Yeah, there's a lot of applications, audio applications using AI right now, but you have different applications. Of course, there's these generative models that are used like to make music, and they sound kind of shit.
Yeah.
Like it doesn't sound very good so far. But I think what is very interesting is using AI as an assistant to the musician. And there's, for example, a company called Ozone. I mean, they do really like Isotope. Sorry, Ozone is actually the product. So Isotope, they do really cool stuff, and they have a software called Ozone, which is used by a lot of music producers, and they have like a kind of AI assistant which will basically guide you to mix your music, because like mixing is very difficult. Like if you have a bass and a guitar and a lot of instruments, takes a lot of time to make your mix sound good. And basically they can assist you to do your mix, and basically also mix you help you for the in the mastering process. So once you mix your music, you need to make it like sound big and nice. So after mixing, there's a process called mastering, and they can also help you with the mastering. I mean, there's a lot of work on like AI assistants, which I think is very interesting. But also, there's a good amount of work like currently done by Google to like do some very interesting stuff like mixing audio sounds. Like you can mix a sound of a cat with a guitar, and you get something weird, and you can play with it. So if you need some inspiration, that's actually a good starting point. But I think can get distracting at some point, because now like you have so many instruments like this. With these virtual instruments, you have like the choices are just unlimited, and when you have too many choices, you actually spend more time choosing the right sound than actually making music. So it can be like curse and a blessing at the same time.
How much do you think is like, where do you think the crossover will be in terms of like, I know we're diving into like the music category now, but where do you think the crossover will be between assistants and actually doing the work for artists, right? Because I would imagine at some stage AI is going to get so advanced that it could probably just replicate what we've currently got on the market today in terms of any kind of music genre, right? And I guess, where do you think the crossover will be in terms of an artist using an assistant to help with stuff like mastering and mix down and stuff like that? Actually the assistant is just creating the music and you're just the face of that brand and that music, right? And what do you think about it? Because in my mind, like, the artists that I follow them because I know that they create that music themselves, right? And it's kind of that tangible, real, like organic thing. An artificially created like thing that's just going to replicate sound that does well in the charts, right? Or does well in a particular genre. So like, where do you think that crossover will be? And like, what do you think about that? Because as an artist as well that produces music, you yourself have got an emotional bond and an emotional tie to that music that you create, right? Because it's yours. So I don't know. What do you think?
Yeah, that's a really great question. It doesn't apply just to like music production, but also to art in general. I think like as long as you keep your identity as a musician or as an artist, it's fine, because like as a musician you have like a certain sound. Like if you hear like music by some artist, like even without looking at the title, you can guess like which artist is actually playing that music. So I think as long as that identity is preserved, and just AI is just helping you with inspiration, reduce your time spent at the studio mixing and mastering, that's totally fine. And I mean, there are also like a lot of artists, like painters, for example, using AI for inspiration. So basically what they would do is they will give to the model a bunch of paintings that they have already done before. and the model would generate new paintings, but they are not going to use those paintings directly and claim that they did them, because that would be a scam, kind of. But they would all just look at them and say, oh, I'm really inspired. I really like this one. I will make something in that direction. And I think this is really the thin line between like AI taking over and artists is just using AI as an assistant. So it's the same thing for music, for example. Like sometimes you get stuck, like you're making a track. This is like the biggest problem with musicians, is that they don't finish their projects. It's a huge problem. Mm-hmm. So you start making a track, and then like you're very excited in the beginning, but then at some point you're like, oh, I have another idea, and then you jump to another project, and then you name your project Unfinished Track number 1. You start Unfinished Track number 2, and then you end up with so many unfinished projects, and you need to get back and finish those projects. And I think if you have a kind of AI assistant that can help you at least finish these projects, that will be a huge thing, really big thing. So like you would ask yourself how it would help you, but basically what it could do is that, let's say you started a track and you're very happy with the intro, you have like kind of the hooky part of the track, you already figured that out, but you don't know how to structure your track. So that what would be very interesting is something that takes that and tells you, oh, maybe you can like extend this part like 16 bars, or maybe you could add a new instrument here because it would sound like more interesting until you actually finish the track. Because like if you're making music alone, you always have this issue. So you're kind of stuck with your own ideas, which is at some point like get boring. So if you have like another perspective, like by AI that tells you, oh, maybe you can add like some piano sound here, it will sound really great. And then you test it and you're like, wow, that's interesting. And since it doesn't come from you, it comes from someone else. In this case, it's an AI. It becomes more interesting. So it keeps things more interesting, I would say. I mean, I don't know of anything like that like right now. There's nothing like that can help you.
Yeah, I think the closest thing that I can think of right now is actually there was an automated thing released on GitHub recently where it was like a coding helper. I can't remember what it's called. You've probably come across this, but it's effectively Copilot. That was it. So I think it would help you code when you're writing code. It would suggest like different parts of like what you can insert and stuff like that. I don't know how well that's doing at the moment. I know there's a bit of controversy about that in the industry, but I think, yeah, if there was something like that in the music industry, man, that would be... Have we just stumbled across a really good business idea?
Yeah. Yeah, I think that could be like really interesting. I would personally use it because I make music alone. And as I said, like when you have an idea, so it always starts with an idea, right? So you have this idea and you try to make, and usually this idea is like, what is it? Like 5 seconds? Like, so you need to take that 5 seconds and make a 7-minute track out of it. It's very difficult. So, like if you really have like an AI that could take like that 7-second idea and just suggest like different directions, it could be like super inspiring. Yeah, I mean, the same way as I said, like these people like using art for inspiration. It's pretty much the same thing. Like when you have a bit of choice, not too much choice, very important. Because if you have too much, like you're just lost. But if you have some good suggestions on the spot, it's exactly like if you're making music with a friend and your friend says, oh, maybe you could try this. Maybe we could start like the bass with the bass and like kick and bass here. It's exactly the same thing. It's just that when you're making music alone, this can help you a lot. But when you're making like music in the studio, like if you're like a successful band, you have a music producer, you have a co-producer, so you have other people that are helping you with the music. So but like electronic music, like most like you're making music alone, which is more challenging.
I guess the question there is, because you probably know this, in some pieces of art and music, there are specific things in those tracks or those pieces of artwork that are really the big draw, right? So it might be a melody, or it might be some sort of hook, or it might be the bass line of like something like that. And if that one thing has been suggested and created by music that's made that track successful, it's kind of like, who was actually the successful artist there, right? Was it the AI, or was it the person that just took that idea and then pushed that into their track? So I guess that would be emotionally, if you knew that internally, I don't know how you would feel about that. Because I know if someone said that track is all about that, and that's what makes that track, but deep down, fuck, I didn't even come up with that idea. Was that a good thing?
Yeah, that's awesome. But that's actually very interesting that you say that, because I mean, the reason why you would start making a track is because you already found that part that would make the track interesting in the first place. Because I mean, you could definitely just go there, and just ask some AI to generate a bunch of stuff. But I mean, here the point is using AI as an assistant. So you already have an idea about like the direction of the track. So you, like, for example, you came up with a sick kick and bass pattern, or you found out a great melody, but you don't know how to make a track out of that melody. So you already found the hook, like the most important part of the track. Now it's just about making a proper song out of it. So but if the AI was the one that found that, so you need to do fit AI.
Yeah, it's
you need to mention that AI as a feature.
Yeah. I guess it's kind of the difference between like an architect and a builder, right? And who owns the rights to the design of that house? It's always going to be the architect. I guess if you looked at an AI model that would be able to, or an AI program that would be able to help you build out tracks and lay down infrastructure and flow and stuff like that, maybe that would be okay. But I mean, I've not spoken to anyone about AGI for such a long time, but do you think we'll get to a stage whereby we're really going down the music AI route now, but like, do you ever think we'll get to a stage where artificial intelligence will become so advanced that it will be an artist in its own right? Because the way that I'm thinking about this now is there's a company that I'm actually got on the podcast later on today called Brainamics, who are they're analyzing like brain I think it's called ETG data, and effectively they're doing it for gaming, right? So they're going to analyze how addictive games are and what parts of your brain switches on for different parts of the game, and like how can we make the game as addictive and like interesting and as like complex from a brain stimulation perspective as we can. What I'm thinking is, if you applied that to a music genre, right, and thought, right, how can we make this music as euphoric as possible, so it kind of taps into like this extra euphoric part of your brain, or how can we make this as like cathartic as possible, where it taps into this like instant sadness part of your brain that's just going to be like hyper elevated. And if you could combine brain and ECG data with kind of production level software that would create that through the use of artificial intelligence, we could create like a completely new music genre that would just like send your brain into like another world, right?
Yeah, very, very interesting. But I think with music and art in general, it's really it depends on people. So you could have a track which is like kind of like slow deep house thing, and for you it's actually really good dance music. So it basically makes you want to dance, but for other people they will find it super boring because they want something like much faster. I don't think in art you can generalize this, because you have this personal taste. I mean, of course, there are stuff that all apply, like that apply to all people. Like if there is a very, very sad song, and most of the people agree that it's sad. So, yeah, I mean, it could be, but but I think it should be personalized because everyone is different. Like and also it's not just that; it's also the mood of the person is very important, right? Like if you're not in the mood for dancing music, you just want to listen to some, let's say, classical music or whatever. Um, I mean, even though, like in another situation, you would actually really enjoy that track, like and dance to it. But it also like depends on your mood. If you're actually up to that, like during that very specific time, yeah, gets complicated. So maybe you need to like some brain implant that tracks all of that
Yeah, man.
based on your personal preference and also your mood. What kind of music you should listen to.
Well, have you seen
Yeah.
have you seen
Or
the
you
film
just
Her?
no.
You've never seen it? It's got Joaquin
No.
Phoenix in it, who's an incredible actor, obviously, but he plays some single dude that is like in his mid-40s or something, and basically they've released an operating system that's like a hyper-personalized AGI for relationships. And the voice is played by Scarlett Johansson, so it obviously sounds incredible. And yeah, basically, it's just an operating system, but it's done in like this AGI kind of way. And yeah, it could be something like that, man, where we could build some sort of like AGI hyper personalized music producer, but specifically for exactly what you want to hear at the exact right time, for the exact task that you're trying to do, right? Do you think, like, and honestly speaking, do you think the future will ever get to a place like that? Because I would fucking love it if it did. But do you feel like that's a place that's like 50, 100 years off? Or do you feel like that would be something that we would experience in our lifetime? Because I really hope we would.
Is it in specifically in music or
Just
like
like
anything
generally speaking,
else?
I guess.
Because
Like,
it depends. Yeah, I think I would say maybe 10 to 20 years, depending on different factors. Um, Depending on the funding, you need money to do these projects. There's not a lot of funding in music, so most probably they would not be available for music, but maybe available for more interesting applications, maybe in healthcare or something like that. Like technology wise, I don't think we are too far, but it's all about taking the technology and making kind of product out of it, which are two completely different things. But yeah, I don't think we are like on the technology side, we are not too far. But again, it really depends on the application because you need data for that application. If you don't have data for that application, like there's no way you can develop something that can be used by a lot of people. Like even though, like in theory, the technology could do it, but you still need like a lot of data. Like if we take that for music, you need a bunch of data from different people. They're testing music, etc., which is very kind of difficult to get because that changes a lot, and you need to track. You need to find people that give you consent to track the data, of course. Yeah. So it's not just the technology. It's more, I would say the problem would be more like getting good data and large scale set of data to make the product. Because again, like the product is not the technology. Technology is just part of the product. So you have the technology, you have the data, you have meeting expectations. So all of that, you put it in a mix and you get a product. So it's not the technology. I would say it's more of the data. data problem, I would say.
And so you've obviously touched on kind of like different applications and stuff there, right? And the challenges around that. I think that probably leads us quite nicely into what you guys are doing at Mobius. Because you were one of the founding team, right? And you kicked off Mobius in 2018. So, I mean, maybe for the listeners that don't
Correct.
know what or who Mobius is, maybe give us a high level overview of what you guys actually do, and kind of just give us the foundations of you guys as a business.
Yeah, sure. So we are Mobius Labs. We are a B2B computer vision technology provider. So basically what we do is we work with other companies and we uh, help help them solve computer vision problems. So we basically deliver SDKs to our clients, and we focus more on on-premise solutions. So we don't do APIs. So basically, we send an SDK that will run directly on the servers or devices of our clients. And this way they can do as many calls as they want. They have their data protected because they don't have to upload any data. They can process data in real time, which is not possible with APIs in some situations. Yeah. And on my side, what I work on at Mobius is more on the on-device side. So because we have two types of clients, we have clients that use like servers, like with GPUs, and we have other clients that use like smartphones or satellites or something like that. So the type of models that you would run on the servers, because they have more power, are very different from the ones that you would run on a smartphone or a satellite, because you want to preserve power, etc. You don't have a lot of memory, you don't have a lot of compute power. So I focus more on the on-device part of the computer vision solutions that we provide.
Awesome, man. And you were one of the founding members of the business, right? So, I mean, how was it kicking off Mobius in the beginning? Maybe kind of set the scene for us so we understand how it looks from when you started day one. How did that feel in the business, and how did you guys work together?
Yeah, I mean, it was very exciting. So we started. When we started, we were focused more on on-device, more for smartphones. So we were focused more on like Android, on the Android side, and then we started shifting, like not shifting, but adding more features like on the server side, because there was like demand for it. People want to run their models on their own servers. They don't want to use APIs. Some people want to use APIs, others they don't want to use APIs for privacy concerns, for speed, volume. Like if you want to process 200 million images, it can get maybe expensive. But also the ability to adapt your models. So because with our software, they can just give few samples and they can train like their own models without any assistance. So typically the clients that would use our software, they don't really need any machine learning knowledge. They just need feed data, have like some black box that predicts, and that's it. So like if you have like an API solution, maybe you need some engineering team that will take that and try to integrate it. So that's how we are a little bit different from other people doing computer vision as well.
So you work fairly agnostically with clients then, right? So you're not specifically down to a use case per se. It's more to do with what device that's built on, right? So either on-prem, on device, but the actual application and the actual use case that you work with customers can be completely different from customer to customer, right?
Yeah, it's a great question. It's yes and no, I would say. So we have clients like on the on-premise side, it's mostly same applications that are distributed to different clients, just with a little bit of customization, just a little bit, which is great. For on-device, it depends. So what I work on more actively right now is in the space sector. So remote sensing. In remote sensing, you cannot do that. It's just not possible. Like you need to adapt your models to the data because data from satellites looks completely different from like your natural images, your cats and dogs pictures. Like if I tell you, for example, and you only know that after like working on a couple of projects, because I think there's a big misunderstanding in the computer vision field that you can have something that detects certain things. So, for example, let's say we want to build a model that detects hot dogs, for example. So basically, what you would do, you would get some data of different hot dogs, different lighting conditions, blah blah blah. Train your model. It will work in most use cases, like if you put your hot dog like if you take a picture of your hot dog with your smartphone with whatever, it's gonna work. It's fine. It doesn't work like that in remote sensing. You cannot have, let's say, a model that detects clouds, for example, because the data looks completely different. Like clouds taken by a certain satellite look completely different from clouds taken by like pictures of clouds taken by another satellite, and you have different resolutions. Like in terms of meters, you have different resolutions. You have different types of data. Like it could be like like a SAR image, which doesn't have in cloud, and or you could have optical image, or you could have like different hyperspectral channels. So you cannot just go there and say, okay, I have like universal solution that detects all types of clouds. It doesn't work like that. So, and that changes like the product completely, because then you need to think about like how you could tackle all these different situations. So basically what we do is that we will have like a base model that has like a general understanding of different things. But then we want to adapt that model to different use cases with less data. That's the most logical thing that we could come up with, because as I said, like if a client wants to detect cats, that's quite easy. You could have like the same software that detects cats and you can distribute it to all different clients. But you cannot do that in remote sensing because the data just looks completely different from one client to the other, and maybe their definition of things is very different. Like, let's say they want to detect vegetation. It's a very blurry concept. Like you cannot define it properly. So yeah, that's really the challenge is how you can adapt to different scenarios with less data, and that's what we try to do. And that's for remote sensing, but that's not necessarily a problem that you would face in other applications.
I guess with the remote sensing part as well, all of the targets that you're looking at are ever changing objects, right? So clouds, obviously, as an object, they move and they change, and there's different formulations of those clouds, right? So that must be very difficult to, as you say, build any kind of, well, you can't build a universal solution on that, right? Because you're trying to deal with a moving target that hasn't got any kind of like form or structure that is solid and replicable, I guess. Um, how did you guys approach that problem then? Like, what was your starting point, and how did that transition over the time working on those use cases?
Yeah, I mean, our approach is kind of straightforward. Is that we will design our own models because we want to run them on different devices. So first, we understand a little bit the hardware, like on which these models should run. So then we basically design our models so they are compatible with these hardwares, because you cannot just take any model. Like, you need to make sure that this model will actually fit the memory requirements and software requirements that should be run. That the yeah that the satellite would require, or a smartphone would require, etc. So we start with that, and then we design our model like architecture, and then we try to figure out like what data we would need to build like you kind of general knowledge model that understands basic concepts. What is a, let's say, what is an airplane? What is a solar panel? What is something else? So once we have this general knowledge, we basically take that model and adapt it to new data. And and that's basically our approach for most our projects. We really work hard to get like very good base models that have very good understanding of general concepts, because once you want to adapt them, it becomes much easier. Because I mean, especially in remote sensing, you don't have a lot of data. You might get like one or two or maybe 10 images of certain region. So, and you cannot even like source data. Like, you cannot, like, for example, let's say that you want more cat images. It's very easy to get more cat images, right? But if you're trying to detect a very specific airplane, very specific model of an airplane, I mean, you cannot like find those images. It's just not possible. So you're actually stuck with.
You can't Google them, then, no.
You have, and you can. Yeah. It's very, very difficult, but that's really the challenge, is to work with less data. I would say most computer vision problems are easy when you have data. But really the challenge is when you don't have a lot of samples of something very specific and can be confused with other similar objects. But yeah, I mean, still work in progress. We have done successful projects working with very less data in the space sector, which is really great. I'm currently working on a competition, which is driving me crazy, where you have like 10 samples per concept. Yeah, and yeah, very, very challenging use cases, but it's also very interesting.
Cool, man. And you work on, so correct me if I'm wrong, but that's more on the kind of server on-prem side of things, or is that still on the kind of like edge device side of things?
Yeah. So as I said, we do both, like on-premise GPU servers, etc. We also do on-device. I work more on the on-device side, but you could still have like clients in the space industry that don't want to run the models on the satellite directly. They want to like process the images on the ground on a GPU server, because they already have a bunch of data. I mean, the motivation to use on-premise or on-device really depends on what you want to do. So people will be very interested in running models directly on satellites so they can save on power. And because like, if you don't, let's say for example, you have a satellite and it's sending data to Earth and it's sending a bunch of data. There's a lot of that data that is completely useless because it's either crappy data or covered with clouds. You cannot see anything. There's no point to send it to Earth. So if you have a model that runs directly on the satellite and basically helps you clean that up and only send useful information, or maybe you don't even have to send the images. You're only interested in the intelligence.
Mm-hmm.
How many airplanes are in this airport, or blah blah blah. You don't even need the images. You just need like the number, for example. So that can save you a lot of power, because sending data to Earth takes power, but also you're also not stuck with a bunch of useless data. So you only have like useful data that you can work with. But I mean, as I said, there are other situations where companies want to process the data because they already have a bunch of data already, and they could leverage a good GPU to process. So yeah, depends.
Cool, man. I mean, that's quite the stuff that you guys are doing in space and satellite imagery is obviously quite a unique use case, right? So was it the original plan to work on those kinds of use cases, or as the business evolved, did use cases come up and you thought we could do that? Like, was that more of an organic evolution of you guys as a business, or was that more of a, right, this is where we could apply what we know and these are the industry verticals that we could work on, let's target those? Or how did all of that kind of formulate?
Yeah, that's a good question. I mean, we didn't start with that intention to work in the space sector. We just kind of like doing business. We figured that it's a really good space. Funny. It's a good. Yeah, it's a really good field where you don't have a lot of machine learning used yet on for on device. So it's just like when you're having a startup, like you need to explore different directions because you would have some assumptions, and but you don't know what you don't know, you know. So once you start like exploring, then you end up say, oh, we could reuse what we already have in that space. So for us, for example, how it started is that we already have we already designed like object detection models and object segmentation models that run pretty well on device because they were designed on that. So working in the space sector was just taking those models and adapting them to space data. Because I mean, the rest, there's still some engineering involved because like if it's a smartphone, it's an Android SDK. But if you're delivering like software for space, it's not Android. So of course, like the software is a little bit different. But on the computer vision side, the base, as I said, the base models that have this general knowledge, they were adapted to the space data. So it was like a natural transition. And also very, very interesting because we do both like on device and like we work on premise and on device. And in the space sector, you have very good applications for both. So it just made sense. Yeah. It's also one of the few sectors that are not saturated with computer vision.
Is that Do you think it's not saturated?
Huge potential.
Yeah. I was going to say, because there's such a huge potential for applications of computer vision in the space industry, right? Do you feel like it's not saturated because it's such a difficult industry challenge and topic to work on? Or is it more of a kind of commercial business processy thing that makes it super challenging? Because I'd imagine a lot of the companies that you work with or organizations you work with will be government organizations, right? And we all know what government organizations are like to work with. So do you feel like, what are the kind of blockers for people to get into that industry and work in that? Because you'd imagine it would be like hot topic stuff, right? So why do you think it's undiluted?
Yeah, great question. I think there are many things. So on the application side, there are so many different applications because you could have, as I said, the same use case, let's say detecting clouds, but the same use case looks completely different from one client to the other. Very, very different. Like some clients would want just to get like a cloud coverage as a percentage. Some others, they want to actually get more accurate masks, segmentation masks. Um, some others, like they would do it like as a coarse segmentation. So they would actually classify patches of the image. Um, some others, like they could work with lower resolution images. Some others, they work with very high resolution images, 10,000 by 10,000 pixels. It's just that even though it's the same problem, um, it like the solution can change drastically from one client to the other. And also you have a lot of different applications. And it's and also it's not just the pixel values, but it's also time. So in the same region, you could have different images, and you could say, for example, you could track the activity in that region. So it's not just, you can see it like a video, for example. So it's not just the image, it's also the temporal information that you have. So you have a lot of different applications, and these are very important applications. Actually, they can save lives and very serious stuff like floodings, wildfires. This stuff like are very, very important. You have that, but you also have the technical challenges, like on computer vision, machine learning side. You don't have a lot of data. So you need to come up with your own few-shot learning logic. Because typically in other applications, let's say not remote sensing, detecting cats and dogs, you suppose that you have enough data. You suppose that you have a bunch of data, you can just train this model, whatever, you get a good model. Doesn't work like that in space industry. You have very limited amount of data of things that are very difficult to, even for you as a human, to maybe recognize. So you cannot even annotate it yourself. So you need an expert that will tell you that this is an airplane, and you look at that images and you're like, really, is that an airplane? So yeah, the data is very difficult to work with. You don't have a lot of data, so it's very challenging, and it just pushes you, like on the computer vision side, to come up with better ways of training models with this data. And also, on top of that, you need to make your models very small and power efficient so they can run on satellites. And in many other applications, you really don't care about that. You would just take the biggest model that would give you the highest accuracy, right? And actually that part, just that part of making sure that the model works on the device, it's very difficult. Because I gave a talk just a few weeks ago just about this. You have so many constraints. You have constraints on the hardware. You have constraints on the software. Like when you're designing your model, it should be compatible with both. So you cannot just come up with things and say, oh, like it's going to work. You're very limited in your choices on like how you design your model, because you need to make sure that it actually works on those devices. And that's something that is not really a big deal for other applications, because you just take any model that would give you a good performance, and you don't care about the details, like what you're going to use in this network. But like in our case, that's very important, and we spent a lot of time just to figure out which architectures are giving good accuracy, but also will run on some GPU, like edge GPU or CPU, etc.
I was going to say,
Yeah,
Hicham,
you have challenges on many levels.
I was going to say, do you work with any kind of like custom like hardware suppliers or anything like that, or do you work with like, do you typically use kind of like NVIDIA GPUs and ASICs and that stuff, or do you work with any custom suppliers? Because I don't know who the government organizations and the satellite companies and the space companies are that you work with, but maybe there's, and you can tell us, but maybe there's some kind of restriction on the kind of, you know, the hardware that they use from external suppliers because of what they do. So do you work with kind of private companies on that side, or do you have to work with the hardware that you're given from kind of a customer side, I guess?
Yeah, great question. So there are companies that have already built the satellites, so they already have the hardware, right? There are companies that are building the satellite, and they want to have computer vision capabilities, but they are not sure which hardware they want to choose. So we can help them with that, which we already did before. But there are also companies building hardware or software that is optimized for space applications. So we are currently working with a company that only makes hardware that is really designed for these expensive satellites. Because I think that one thing, the small difference is that not all satellites are the same. So you have the small satellites that you can kind of YOLO in space, because if you lose them, that's not, I mean, you lose some money, but it's not like crazy. But the tasks of these small satellites is not the same as the very big, expensive ones. And the big, expensive ones, as far as I know, don't have very good hardware capabilities for advanced computer vision. And there's a company that makes really good hardware just for that type of applications. So for these very expensive satellites, because you cannot just YOLO them because they cost a lot of money. So you need to make sure that the hardware that runs there is very high quality. You cannot put any hardware because it's just you can put like a Jetson, like an NVIDIA Jetson in a small satellite, but if it's like a very big satellite, it will go a bit far. Things get a little bit complicated. So there's a company that we work with, and they are specialized in building high quality hardware that can run machine learning models on big satellites. Yeah. Well, there's also another company that actually designs software, because something is interesting here is that some satellites are very old, right?
Yeah.
Because they were built a long time ago. And they're still using very old software, like some very old operating system. You cannot use any of the new softwares like to run machine learning models. So there's a company that kind of specializes in this software that can basically support this kind of old operating systems and stuff like that. So Yeah, we really like to partner with different companies for different applications. So what we do is we build the models, and we can partner with another company, as either a hardware company or a software company, because we have a good understanding of both, like the computer vision problems, but also how to run these models. So we know the restrictions that a client would be facing either on the software side or the hardware side.
Got you, man. Yeah, dude, we're at the hour.
Yeah, but wow.
We've got to, I think we've got to wrap this up, man. But yeah, dude, honestly, it's been really awesome to speak to you, and I think yeah, it's been really cool to talk about music and Mobius and everything in between, man. So I guess the final kind of questions that I wanted to kind of land to you is probably twofold. So number one, it would be good to understand where you see Mobius kind of progressing and transitioning over the next like 5 years, and then also how you think the general kind of computer vision industry is going to look, because there's some incredible use cases that are, and some incredible research that's released on what like a monthly basis now, right? So it would be good to understand from your perspective where you see Mobius kind of progressing to over the next half decade, and then also just how you see the computer vision world transitioning, generally speaking, because yeah, I feel like the next kind of 5 to 10 years could be a huge ramp up. But what do you think?
Yeah, I think on the computer vision side, it's going actually in a really good direction. Like just this year, there have been like so many great papers, and you can spot a pattern there is that they are using less and less annotated data. So I think it's going to continue in this track, like using enough data, but not enough annotations. So, for example, a bunch of images, but you don't have a lot of annotations. So self-supervised learning, semi-supervised learning, few-shot learning, I think it's going in a really good direction. It's because really here the challenge, as I said, is the data. Like if you have enough data, you can train a really good object detection detector or segmentation model or whatever. The problem is not training these models. The problem is working with less data. And we are going in very good direction so far. I think self-supervised learning is very exciting. Like how to maximize the knowledge that you get from data without having access to any annotations. Something that I work with, and especially for the space industry, it's very interesting because, as I said, it's very difficult to even for a human to annotate things. So if you have few examples of things that you're sure they represent the things that you're looking for, but you have a model that actually is really good at finding these patterns without needing any guidance, like with annotations, that would be really great. So I think we are going in that direction. Very excited about the next DALI that would generate cool animations. People have started to apply that to videos, which is also very interesting, like generating videos, generating images, and I hope later they will work a little bit more on music, so I can actually use that.
Yeah, man, I'm looking forward to it, dude. I'm looking forward to it. But
yeah,
Hicham, honestly, man, thank you so much for joining me on the podcast today. As always, it's pleasure to speak to you about music, AI, all of the good stuff in between. And yeah, thank you so much, dude.
you're welcome, and it was really a pleasure talking to you.